welcome back. So we have covered this unsupervised learning. We talk about clusters. Now we are talking about topics, a group of topics in text mining. I asked you to review the source code in the slides, to review the content. And I think something that we are ready to do is to start working with that topic. And as I can ask you to do some kind of project work, homework quiz, right? The only thing that I missed, I didn't finish in the previous lecture, is about the evaluation. So I want to do two things today. Number one, I want to talk about the evaluation. It's a very short thing. Again, as you can assume, there is going to be a class evaluation. And the class evaluation is going to help us somehow to do the evaluation. And the evaluation is going to give us a number. And this magic number is going to be the one that we're going to compare one model with another version of the same model, right? It's kind of, at this point, you know what to expect. Okay, so if I tell you how to evaluate your models, then the next step is you can create a model and give me kind of a good version of some model, right? Okay, in particular for text mining, I want to ask you two things. Number one, let's work with a team. Obviously, you are free to work individually if you want, but for this particular assignment, I would like you to have working with a team. So if you have friends and you want to work with your friends, let's make teams of 3. Second, what are you going to do? I really want you to work with a data set that is interesting for you, that is relevant. Think about things that you can analyze with text mining. Think about papers that maybe you have read and you have the possibility to create these TXT versions. Think about news. Obviously, option A, option B for this situation. Option A, you can go to the link that I shared with you about the data sets that are already there, and you can use any of them, any data set that correspond to text documents. You can search for that. Is something that you can use. I am okay if you randomly select one data set of news, emails, or whatever is available there. I will suggest, or I will prefer, if you have something that is yours. Usually, for something that is online, those are good for reviewing that we are learning something, because we're going to kind of check that something is moving, and it's like, this should be working because it's moving. But if you work with your own data, whatever papers, notes, something that you have there, not use your emails because that is kind of personal information, but anything that you could have available, text that you want to analyze, your notes from your classes, could be interesting to see if you can create a program that could identify your notes from this class and compare with another. Anyway, data set. Any data set, you're free to select something with your team. Makes sense? And finally, with your team, with your data set, to create a model that identify the topics, a group of topics. How many topics is something that I am okay with your own selection. Remember, the number of topics is something that you specify. I do not want to give you a number because the number of topics could depend, or is going to depend on the information, the data set that you're going to use, right? Following with my example, if you want to identify or create a program that identify whether or not these nodes belong to a particular class or a particular course, well, the number of topics is the number of courses that you're taking, or the number of courses that you're going to provide as information. So whatever. It could be something like 2 groups, A or B. It could be something like 5, the number of courses that you have. Up to you, define the number. Something that I am going to add you is in your report. As usual, what I am going to add you to submit, to give me, is a paper. Your paper includes your source code. Your source code is the same source code that I am using. No big difference in terms of programming, but mostly your parameters, the parameters that you're going to use. And as usual, your paper includes a justification of why those parameters, why 5 groups or 6 groups or whatever alpha, beta you're going to use. Good? your team, your data set, final result, a paper, your paper, obviously, description of your data, your source code that is going to be mine, but with the parameters, an explanation of the parameters that you're using, your results, and your conclusions about the results. This work, didn't work, why? Clear? Okay, let's put this as your next quiz. So people can recover from the previous one. One more quiz, less value for all the quizzes. Make sense? Okay, now let's put a deadline. Guys, you can finish in a couple of hours. In fact, my plan is to finish this early. I am not going to use the full hour. Hopefully I can use only 20 minutes or 40 minutes. You can start working with your team right now, or at least create your team. So you are not posting announcements later about I do not have a team. So you can do that by the end of my talk. But let's put as a due date before our next lecture. Why? It's a quiz. I want you to finish as soon as possible. Moreover, I want to have this done before we start with the next topic. So a quiz, due date, before the next lecture. And before the next lecture, literally, 11:59 a.m. Next Thursday, this Thursday. Click, due date, submission. It's going to be a link on Canvas, don't worry. And the goal, text mining, data set, whatever you want to use. Good? Okay, the only thing extra that I need to share before you can start working. We review everything. You have the source code there, and I put at the end of my lectures. But one more thing, the evaluation. For the evaluation, guys, important, 2 elements. Number one, we cannot evaluate one model, apples, compared with another model that is for bananas. So if you are going to work with your data set of papers, and someone else is going to work with the data set of course notes, the number here could be better or worse than the number there, and they are just not related. Your model with bananas can have a number -10, and a model with apples can have a number -20, and that doesn't mean that this is worse than this one, because it's just different data. The only thing that you can do with the number is to compare different versions of the same model. So I am working here with apples, and I get -10, and then I move some parameters, and I have here the same model for apples, the same apples, and now I get -12 or -9. That have a meaning. Compare with my previous -10, right? So the number is used for your same input in different versions of your model. Done. What is the comparison that we're going to use? In unsupervised learning, theoretically, the comparison of models is going to be with the likelihood or log likelihood. So far, you get the idea. Negative log likelihood, or use log likelihood, or use likelihood. The only thing that is going to change is if we add the log, the number is going to be small. And if we add the negative, okay, we remove the negative and it's going to become a positive number. But we're talking about the same, likelihood, probability. Okay, there is this idea that that likelihood or that probability is a good measure of unsupervised model. Let me be clear. Is a proposal in a particular paper from a particular group of people, and it's something that usually works, but it's not a rule. It's not like 2 + 2 always 4. It's a theoretical idea that likelihood is a good tool to measure unsupervised models. Not 100% correct. If you want to read all the description, this is a very good source. That is the proposal of likelihood for unsupervised learning measuring. And I put this paper on Canvas if you want to take a look. My point is not perfect. You cannot measure unsupervised because you do not have the answer. So the best thing that you can do is to check the change of this probability measure about, okay, this model can be better than the previous one or not because you use this number. It's a number that you're going to use to compare is not perfect. It's not like measuring the size of the table. Clear? Okay. Being aware of that, just remember, likelihood, big number, log likelihood, a small one, negative log likelihood, negative to positive, something that we can use to measure our models. Source code. Number one, the first part of the slide. If you're going to measure your model, you need training data and testing data. So far at this point, you know, training and testing, if you use the same data, and maybe you notice with the clusters, if you use the same data, the results are very good, but doesn't mean anything. It's garbage. So step number one, something that maybe you're going to want to do is to split your data in testing and training, use like for every other model that you have been using so far. And following that idea, the last lines, the model. For the last lines, the model. The only thing that I want you to notice here is the one in yellow. From the thing in yellow, I want you to remember that add instances was the method that we used before to add the data for the model to be trained. And before we pass everything, we pass all the instances. This time, I want you to notice that one change that I have here is I am passing not all, but something called an array in the position 0. And I am sure that you're curious, like, okay, what is this array in the position 0? We can review above. And above, we have these instances that we already have, remember? And we have a method split. The method split of the class instances is going to return an array of instances list. Instances list with how many elements in that list? 3. So you have a method split, yes. And that method split is going to return an array, yes. How many elements in the array? 3. An array of what? An array of linked list. List, whatever. It's an array with 3 elements. Each element is a list. A list of what? Instances. What you had before was just one big list with all your instances. One data structure. Now you have not one list, but 3. And the best way to return those 3 is in an array of 3. 3 lists. Okay, 3. Why 3? Well, because this split is going to give you 3 collections, 3 groups: training, testing, and something else for folding. We're going to ignore the folding. We are not going to do crossover. So I only want to use 2 groups. Yeah, but the array is 3 elements. No problem. You can put the last one with 0 elements. It's not null. It's a linked list with no elements. The null is the connection, right? So you want to split in 2, training and testing. Did you notice what are the parameters for the method split? How many parameters? This is tricky. 1. 1? Yeah, 1. And what is the parameter? An array. And it should be an array of 3 numbers. The 3 numbers, the recommendation is that the numbers add 1. So 100%. Professor, what happens if didn't add 1? The computer is going to make them proportionally. What happens if I pass something like 5, 5, 5? They are going to add 15. Don't worry, that is exactly the same that 0.33, 0.33, 0.33. Is going to divide in 3 equally sized groups. Makes sense, right? This use, you can do the reduction, the unity. 3 numbers. The only thing that you want is training and testing, which are the 2 first numbers. So if you make the 2 first numbers add 1 and the last one is just 0, you're going to have three groups, the last one without elements, and the first two are going to be as many elements as you want for the training and as many elements as you want for the testing. And obviously the recommendation is that your training is bigger than your testing. In particular, something that you're going to notice for text mining is more or less 80 to 90% is training, and therefore 20 to 10% is testing. Makes sense? So my example is 90 and 10. 90 for training, 10 for testing. As you can notice, the 90% or the one that have 0.9% of the data is the one instance list 0, the one that we're going to use for training the model. Now, instead of passing all the data to the training, we just pass the first group, the 90% of the data. Makes sense? Obviously, you're thinking like, okay, and what is going to happen with the other part? The other part is the one that we're going to use for the testing. And as you can notice, is the element 1, that is the second element in this group of 3. You are not going to saw the instance split 2 in any place. We are not using that crossover here. Clear? Okay, so everything else with the model is something that you already have, is something that we already did. The threads, the number of K that we're searching for, and go and train, right? Nothing new. The only new thing is now we pass only a few, 90% of the elements. Now, the evaluation. For the evaluation, neural networks, clusters, we have this evaluation class. Evaluation class here. The evaluation is not so directly. The evaluation, as I mentioned before, is more like theoretical. And therefore, the library itself is going to implement several different classes, several different strategies in which you can evaluate these kind of models. Now, the library in particular works not only with text mining, is not a library used focus on that, have more than that. And therefore, there are going to be several different classes that implement several different evaluators for different purposes. In particular, for text mining, one evaluator that now we're going to call estimator, because we're not really evaluating, because the first thing that we mentioned before is we cannot evaluate because it's unsupervised. Therefore, the class is going to follow this name of estimation instead of evaluation. You know, if you create the library, you can use the names that you want, right? So your class, for remember, marginal probability estimator. Yeah, they didn't want the probability keyword, so marginal prob estimator. And you are going to create an object, and from the object, the slide? Yeah. Let me see. Better? Thank you. Okay, so your class, your object, ask the model to get you the evaluator, well, the estimator. A new instruction, a new object, and you have this guy. And using this new guy, the estimator, you can call your method, the method that is really going to do the work. And again, depending of the object, depending of the class, are the methods that you are going to have. This guy in particular implements several different methods to do this estimation process. One of them, only one of them, left to right evaluation. Left to right, yes, we're going to group characters, words here. And we're going to use them to check if they belong as a group to a particular topic, as a group in the document to a particular topic, and then we're going to compare what we can check, have at the end. Okay, forget about it. Is estimator evaluate left to right, like you are reading, and that guy is the one that is going to give you a number, a double number, and that one is going to be the likelihood for that particular model. Notice, I am talking about likelihood, not log likelihood, not negative log likelihood. So this guy is not going to be a small number. It's going to be a big one. No problem. At the end, the only thing that I am looking for is a number that helps me to compare if my model is improving or not. This is going to be your number. Clear? Now, that number, this method is going to receive a set of parameters. A set of parameters. 1, 2, 3, 4 parameters. The most important one, the test data set. The element 1 in my array above. These are the elements. These are the documents. Remember, each of the entries here is one document. These are the documents that I am planning to use for testing my model. Testing my model. Basically, what I have is I am going to look for these documents, 10% of my documents, whether or not those documents can be put close to one of the topics, one of the groups that I defined previously in the training. Things that are important here. Number one, number of tokens that I am going to consider for one evaluation. Number of tokens. Remember, each of the words in these documents and in the previous ones, the first thing that you do with the documents is to transform them into tokens. Tokens, this representation of the word. The tokens, how many tokens you use? A common number here is to group or process 10 together. It could be 8, it could be 12, it could be any number around 10. Small the number, more time that you are going to need to process the document. You can put 1, it's 1 by 1. Bigger the number, faster the process, but higher or lower, how deep are you evaluating the document? How many topics are you considering? Right now, if I put 10, I am considering one topic for every 10 words. What that means? That I am not doing topic per word. I am doing topic per group of words. The idea is if several times the same topic is the leader in a group of words, that topic is also the leader in the document. Instead of 1, 10. A good number to use for the testing, obviously the training is different. How different do you think are the words in your document? Usually the words in your documents are not so different. Usually with a number around 10, it's good enough for the evaluation. It's good enough to have topics per this group, depending on what you are doing. Now, true or false, whether or not you allow one word to be used more than one time, whether or not you allow that in the sampling, the second time, when you pass another group, one of the words that you previously used can be used again or not. Again, true is going to make this slower. False is going to increase the speed. Obviously, depending on the complexity of your document, true or false could be better or worse. If you are doing your notes for the homework, if you are doing a paper, if you are doing the news, all of those cases, usually the group of words are pretty different from one to the other section. If you are doing emails, and that is a different example that we need to cover, but if you're trying to identify spam in the email, for spam in the email, it's harder to identify whether or not it's spam, because it's not like there are particular words or a particular structure to identify the spam. Like when you have a paper, it's very clear to identify that paper to which category, topic, or conference or whatever belong. Emails are harder. The topics can change drastically. For your documents in general, 10 is a good number, false is a good choice. And the last one, this one, 2 options. Number 1, the only thing that you want is the number. If the only thing that you want is the number, the last parameter is null. The only thing that you want is this number to be returned. Here, This parameter is a print stream object. Print stream, help me, what is a print stream? It's a parent class in Java, right? Which are the childs of print stream? The classes that help you to send data to files or to the screen. Yes or no? Guys, you can create an object, prime wider, and connect that object to a file, and then use that object here. And basically you can send all the partial results and evaluation to that particular object. And if that object is for a file or is connected with a file, you can store that to the file. Or you can use here, what is the object in Java that represents the screen? It's a print stream, right? This one. Java, the screen. System out. System out, and have a method println, right? System out, very bad idea because you are asking to send this verbose information to the screen. And I am sure that you do not want the screen like crazy printing things. The good idea is create an object, print writer. You can connect that with a file, and then you can pass that there as a parameter, and then you can print or store in this file all the details of what is happening in the evaluation if you need it. If not, null, ignore all the partial data and all the process, and the only thing that you get is the likelihood returned by the method. Makes sense? Okay, I am not asking you to do anything with this. However, my recommendation, I am sure that you are going to be curious about saving this data or printing the data. Again, not a good programming thing, but you can use at least one time this print on the screen and check all the information that is created there. That is basically this evaluation running with your testing data. Good. Okay, the number. You can print the number. The blue variable, likelihood, the total for your model. That is the important one. So as a summary, two new things that I am showing you or asking you to consider for your homework. Number one, split your data in training and testing, and I give you the source code for that. Number two, create an estimator, now the new name for the evaluation class, and use it. And get a number, likelihood, for one version of your model, and at least create a second version. Move the parameters and check what happened with this number. Check by yourself that this number here is really going to be different. And moreover, you can check if the number go increase or decrease according with the change that you did in the parameters. My recommendation, you know which parameters are better or worse. Parameters, which parameters can you move in your model, remember? How many parameters for your model? 3? Which are those 3 parameters? Yes. For the keys, literally nothing is going to happen. When you change the key, basically we're talking about a different model because we're searching for different things. But you can play with the alpha and the beta, and you're going to notice what happened. You already know, I shared with you what happened or when a higher value for alpha is good, when a lower value is good. Same for the beta. I give you the values, quotation marks, good values, or the traditional values for the news of the BBC. What happens if you just change those 0.001 to 1? Delete the zeros, 1, 1, and you can see what is going to happen with this number. Again, use curiosity, right? Just do your research, check what happened. Likelihood, log likelihood. What you're going to get at the end of this source code is that now your results are going to include this line in white. Remember, everything in red is something that I showed you before already. Everything in red is the result that we had before. the clusters that we create, the topics, and the numbers that correspond to the log likelihood per token. We already have this, 3 seconds, the topic, la, la, la. This is the only new thing when you add the source code that I checked for you. As you remember, I put this line, and this is the number. This is the number that the estimator is giving to me. What? Huge. Yeah, why huge? Because I use 10% of the data in these documents from the BBC to test my model. And what are the possibilities that with a couple of articles, I really create 5 clusters that really represent or can be used to classify any document? Obviously, that is not true. As you can notice, my groups above, I asked you, like, hey, which one of the 0 to the 5 to the 4 is sport or polity or whatever? For you humans, it's like, oh yeah, that one could be sport. Oh yeah, that one is polity. Ah, that is entertainment. Makes sense. They are good. However, in terms of using 10% of the data to now new documents classify in any of those 5 categories, that is the probability of something good. And the only thing that you need to know in order to tell me if this is good or bad is which one is the value that we are looking for, talking about log likelihood. Right? So this guy, positive or negative, log or not, I don't care. It's far from 0. It is not good. I really don't care. I know that it's not going to be good. Again, it's unsupervised. You are not going to get a 0 with this kind of method. This number can be worse if we start working with bananas. The only thing is you can change the parameters for this model and just compare if this number is greater or smaller than the new parameters, period. And it's always going to be that kind of crazy number. Good? Professor, but why this one is so big and why this one is kind of a little bit better? I mean, 9 and 1 digit and like 6 digits. Divided by number of tokens and how many tokens we have? A lot. At the beginning of the results, the system gives you the number of tokens. So don't worry, you're going to have that number there, but it's a lot, right? We're talking about a token is every single different word in all this collection of documents that we're using. So it's a lot of tokens. And that is the only reason because the number above is kind of smaller, closer to 0. Good? Please. Yeah.
So to compare the different models, we basically want to find the log likelihood that's closest to 0.
Yes. So we want this number to be as close to 0 as we can. Okay. It's never going to be 0. It's never going to be 1, 2, 3, or -1, -2, -3. But we are looking for something close to 0, the better. Cool. Similar with the above one, the -9, we're searching for something that gets close to 0. Now, remember, 2 things, and here is important. Remember that this number is the calculation, the estimation of how good or bad the model is for this particular iteration. If you remember, in my previous slides, I showed you the results with 1,000 iterations. Hopefully you remember that in the slide, and I'm going to put this later, is there is this angular bracket, 1,000, and then there is a number. And if you remember, the number was 8 something, -8 something. So after 1,000 iterations, it's -8 something. The example that I'm showing you here, hopefully you notice, is I am showing you the result at the end, asking for 50 iterations. That are the ones that I asked in the previous slide. 50 iterations. And you can notice that this number is -9. It's worse than the one with 1,000 iterations, which is normal, right? Remember, your first goal in a model is to reach a point in which the difference between the 50 and the 49, or the difference between the 1000 and the 999 is almost nothing. So the point in which the model reached this kind of stability point. What I have here is, if you run my model and you compare the 50 and the 49, you are going to notice like the change is big. And a big change, I am talking about that maybe this 0.0 in the previous one, instead of 0.0 was something like 0.1. So it's like, okay, from minus 9.1 move to 9.0, minus 9.0 is like, it's a big increment. Yes, 0.1, one decimal is big. So in that moment, you know that it's like, okay, we need to run more iterations. And maybe from 50, you move to 100 or 200, or you can go directly to, as we mentioned before, thousands. 1,000, 2,000 is a good number. I move or I jump from 50, that is for use training, playing, checking the model, to 1,000. And in 1,000, I found this minus 8 something. And if you compare my 1,000 with my 999, you are going to notice that the change is not a number here or in the second position or third position, but it's more like in the last 2 digits. And when you notice that change in the last 2 digits, you still have the option to increase my 1,000 to 2,000, and for sure it's going to be better. But I think you are not going to go down to 8. It's going to improve, yes, but it's going to go down to minus 7, probably not, because of the data. It does not make sense to move to 3,000 or 5,000 or 10,000. You can try with 10,000 and you are going to notice that, yeah, 10,000 hours, several minutes of your computer working, and it's going to get hot, but you are not going to move the numbers, probably maybe nothing in the last 100 iterations. I don't know, depending of how the data is split, but do not make any sense. The resources that you're using, the time and the electricity is not going to improve the model. 1,000, 2,000 could be enough for that particular data set. That is what you are checking here. You reach the stabilization point, you stop, that is your model. Then the next step is this number. This number with different parameters. Maybe this model with some parameters, you run 1,000 times. The second one with different parameters, maybe you need to run 2,000 or 100 or 50. Different parameters can reach this stabilization point in different times, in different number of iterations. But you have two models with the same data, and then you can compare those models in terms of the probability of the model to be able to randomly assign correctly a new random document to one of the categories that you have. It is perfect. It's really a number to represent an evaluation. No, it's just a number that can help you to compare your models and apples with apples, the same model with another version of the same model, period. Those are the two numbers that you have. Clear. So as you can notice, remember, this is with 50, this is with my 1,000, minus 8.64, minus 9.08. It makes sense, my evaluation. Likelihood, I think I changed the parameters here, not remember exactly, but likelihood here, 36, 29, 37. So yeah, look like this is better. Whatever I did, both numbers are better. Again, the number in white is better because I changed the parameters, not because the number of iterations. The previous one and this one have 50 versus 1,000 iterations. Two things that you can do. Good. Okay, that's it. Basically, you have this source code. In one picture, the source code that you need to do text mining. And hopefully, at this point, every single line here makes sense. The evaluation that I mentioned, split data set that I mentioned, the model, and the preprocessing with the files. Is there anything that you need? Other than these, things that you can move here, literally. You can move these parameters. You can move how many clusters you want to create and the alpha and the beta. You can play with these numbers. How many data you want to use for training, how many data you want to use for testing. 80-20 could be your option in some particular scenario if you want to have more testing data, less training. Those two things, you can do it. Other things that you can change is this pattern. Remember, in the example that I am showing you, the only thing that I accept as correct are words with letters and with numbers and the underscore. So anything that could have any other kind of symbol is not being used by my model, which makes sense with the news. I am curious, what kind of results could you get if you use source code in Java, for instance? But obviously, if you want to use source code in Java to compare different versions of one software, that pattern there should change. Again, the pattern itself, line 22, is nothing related with the library that we're reviewing here, nothing related with machine learning. It's just patterns, regular expressions in Java. So if you want to change that guy, what you need to go to review is your regular expression skills and search how to create a regular expression that best match the words that you're going to use in your particular document. Is another thing that maybe you want to change? UTF-8, you can change if you want. You want to use the particular chart set in your computer. My recommendation, my request is keep the UTF-8 because when you submit, it kind of work everywhere, right? There is no reason for you to want to change that. I think so. But well, in general, you can remove that. Other than that, the number of threads. Four is a safe value. Any of your computers is going to be okay with 4 threads. Some of your computers can go up to 8. Some of your computers can go up to 16 easily. Above 16, I will be careful, or at least if your computer starts to stop it, or I don't know. You know when your computer is crazy. So 4 is safe. 16 still could be safe. At least my Mac start complaining above that number. So the only thing that you achieve with increasing that number is speed. I think you could be okay waiting a little bit. My 2 models with 50 and 1000, they run in less than a minute. You notice the numbers. It's kind of a fast process. It's a very easy one. Everything is matrix. And when you split this in at least 4 threads, the operations run kind of quick in any of your machines. So it's not something that you need to change a lot. The 1000, again, my limit, my recommendation, 2000, 5000, if you want to see what happened. Any other is not going to make any change depending on your data set. Good? Okay, this is the source code that you need to play. Your work. The description of your next quiz as a homework to submit before our next lecture. 1. Be sure that you can run in your computer the code that I just presented in the previous slide. I mean, my recommendation is first be sure that you can replicate my results with the BBC dataset. So you know that your computer, your libraries, your thing is working. So step number 1, replicate my slides in your local system. After you have that, then, okay, you can start working. By the way, I am not asking you anything in the paper about show me that you run the BBC dataset. I am assuming that you're going to do it. Select your dataset. As I mentioned before, dataset, select something that is important for you. Select something that you're curious about. Obviously, you can use any of the dataset available online. I don't know. I do not want to ask you to use like previously flowers or other things there because it could be something that you do not care. In this particular exercise for documents, hopefully you can use something, whatever, that are documents that at least the result is going to tell you something. And you can have a feeling about this result is garbage or this result is something really interesting or not. And you are going to have that feeling only if the data is something that you know. If you're using flowers, it's like, okay, flowers, whatever is the result is good. Select your data set, whatever you want to use. Create a model, select your topics. The model is basically the source code that I showed you before, the number K, whatever corresponds to your data. Try different configurations, alphas, betas, even case, if it's something that you are trying to figure out groups. Evaluate your models. At the end, select the best one that you can create. And what I am most interested is, okay, after trying 3 different models, or 4 or 5, up to you, you get this model. And you get this model, and this model is reporting you these groups. Tell me, you think that those groups, that result, the work that you did is good, bad, what you expect, something unexpected. I am asking more about your evaluation, your paper description about the results that you get, and whether or not this source code and this text mining get some use or is useful for whatever work or whatever information you have. Create a paper, a PDF. As usual, this time I am asking you for a team effort. I am okay with teams. So only one member of the team submit the paper. Please put the names. If you're going to work together, 3 people at the top of the paper, put your 3 names. And then, as usual, your models, the parameters, the description of your results. That is what I am looking for. And hopefully, no need to mention this, but please, academic integrity. Do not submit copies. I do not want to make reports. But other than that, it is basically my request for you to play with this tool and check if you can do something useful in your work in other areas with the tool, and show me that you did that you play. There is obviously no good answers, bad answers. If you do the process, if you make a good description, a good discussion with your team, I think it's a quiz in which you can get an easy, good grade, and therefore improve your other quizzes. Yeah.
Do you want us to submit like a snippet of our code or just write the paper?
Put your source code in the paper. I am not particularly interested in running your code because it's going to be, an improved version of my code or something like that. I care about your parameters and I care about your results. Please describe your data set. Again, I am not asking you to submit your data set. If you use something online, you give me the link. That is going to help me with the description, maybe help me to get access to that set. If you are going to use something that is yours, personal, do not give me the data. I do not need the data, but describe to me like, what is this data? It's like, oh, this is my collection of papers from all my classes, and the papers are 1,000 papers. Okay, let's see what happened with these 1,000 papers. I don't know, I am just kidding, right? Whatever that set you use, you describe the data set to me and your results. Clear? Any questions so far, guys? Clear? Okay, I am going to stop here. You can make your teams. See you next lecture. Thank you.